Welcome to the Object-Oriented UX podcast, a podcast about tackling complexity head-on, gracefully organizing massive amounts of information, and designing scalable, future-proof, and of course, naturally intuitive object-oriented user experiences. An OOUXer is a powerful blend of information architect, business analyst, facilitator, and UX strategist. If this sounds like you or what you aspire to, you are so in the right place. I'm Sophia Prater, UX designer, chief evangelist of Object-Oriented UX, and your host. Let's jump into it.
What's up, OOUXers? Sophia here, and I just read a two-part series that I really want to walk you through on large language models and world models. And this two-part series was fascinating. It was long and deep and complex. So I want to give you the highlights. Of course, we'll link the articles in the show notes so that you can read them for yourself. But I'm going to pull out what I think is the main story for us as UX designers and product design people who are starting to turn into AI designers. AI is integrating more and more into the products that we're designing, and we want to make really useful and also efficient AI, right? Efficiency is a big topic in the AI world. Pretty much I have a little tiny guilt trip every time I query ChatGPT, just knowing the amount of energy that it takes. And so this is a podcast episode about an article that brings us into how OOUX is relevant to the design of artificial intelligence and the experiences that people have with artificial intelligence. And I didn't really think about this until I read these pieces about how OOUX can, I think, if my understanding is correct, actually not only help create more useful experiences, but also more efficient experiences. So I'm going to just go through this article, this two-part article, and give you kind of my takeaways. Basically, I'm looking at a Google Doc here of the article with my bits highlighted. So it's going to be casual. I'm going to just kind of talk you through it and then pull what I think is I'm going to just highlight what I think is most interesting about this, what is most relevant, what is most useful and inspiring and exciting about this. And I hope you find it really exciting too. So this two-part series is titled LLMs and World Models, Part 1 and Part 2. It is by Melanie Mitchell, who I have been following her Substack for a while. She is a professor at Santa Fe Institute. And she's the author of Artificial Intelligence, A Guide for Thinking Humans. She works in AI and cognitive science and complex systems. So, Melanie, you are a friend. You are a friend of OOUXers and this community. And if you're listening, hi, I'm going to send you this. So hopefully you will listen. And I would love, Melanie, not only your feedback and thoughts, but everybody's feedback and thoughts. Let's talk about this. So her Substack is called AI, A Guide for Thinking Humans. And again, I will link it down below. And these were published recently. They were still in my inbox. So as of this recording, which is February 15th, 2025, this is probably a week old or something like that. So things change fast in AI. So it's relatively current. Okay, cool. So basically this article is asking the question, how do LLMs actually make sense of their world? And what is a world? How do we actually define what a world is? So she starts to go into this she talks about the AI brittleness that we experienced in the before times, quote, and I'm going to actually quote some pieces from the article as well. But she talks about how if you would change little things about the AI or how you prompt, it would basically break. It was brittle because it wasn't solving problems because it really understood the concepts. It was actually solving problems just using what she calls shortcuts or surface heuristics. So some examples of this. So she gives us a really great example of a LLM that was being trained to look at at skin lesions and classify them as benign or malignant. And what happened is the data that it was trained on, it turned out that when a ruler was in the photograph, that just somehow correlated to more malignant, am I saying that right? Malignant tumors. So it started just thinking like, when there's a ruler, that means it's malignant. So because it was just trained on this data set and it was creating all these little shortcuts, the thing is this AI did not understand what a lesion actually is or what a tumor actually is. It doesn't understand the meaning of it. So it made these weird quote assumptions and, worked great when it was inside the training set, but then you take it outside the training set and it's brittle. It doesn't really work. It also didn't understand the concept of a ruler. So if it had understood the concept of a ruler, and this is my take on this, then it would have been like, oh, I know what a ruler is, and it is not connected. It has no relationship to the causation of cancer or a tumor, right? So it didn't understand the concept of a ruler. It didn't understand the concept of a lesion. It didn't understand the context that it was in, okay? But it took in a lot of data and it was able to make predictions. All right, so this is basically saying that this AI didn't have a world model, really. It just had a bunch of shortcuts. And there's some other examples that she gives. So an AI that was trained to play a video game, an Atari video game. And as soon as the researchers moved one aspect of the video game, just a couple pixels, then this would have never tripped up a human being playing this that knew how to play this game. But it completely tripped up the AI, and the AI's accuracy and ability to play the game completely plummeted as soon as they just moved the paddle by a couple pixels, because this AI did not understand the concept of paddle and ball or bricks. It was just using a bunch of these heuristics. Okay. So to quote Melanie here, she says, in all of these cases, the machine learning system had to learn to perform its task using heuristics specific to its training data rather than the kind of abstract causal understanding the human trainers were trying to teach it. Okay, I think that's really, really important here. So this is where things got really interesting for me. So she starts to go into the debate over emergent world models and LLMs. So I will quote here, there's a fiery debate in the AI community on how they achieve their high performance, how LLMs achieve their high performance. Have they basically memorized their training data and then retrieve it in some approximate way to solve new problems? Have they learned much more numerous and detailed yet still brittle heuristic shortcuts? Or do they have something more like the robust, quote, world models that humans seem to use to understand and act in the world? Okay. So the question here is, so we could really see the brittleness, 3 to 5 years ago. Now we're seeing less of this brittleness, but is it because AIs have really started developing this human-like emergent world model of understanding concepts? Do you see where this is going from an OOUX perspective? Or have they just basically created better coping mechanisms? Have they created better coping mechanisms to simulate that they understand, right? Because they just have lots and lots and lots of more little shortcuts and heuristics and basically ability to statistically predict what makes the most sense. All right, but they don't really have that understanding. There's actually a debate like this, looking into and peeking into the community of AI engineers, basically, and researchers is just wild to me. And then, so basically the article goes on to the debate and kind of going back and forth on what all these big names in AI are talking about and how they're kind of going back and forth. You can read that if you want to. But the end of the story here is the debate is basically 50-50 split, which to me is again, just so wild. We don't actually know. We don't actually know how the AI is doing what it's doing. So I was under the impression that we knew that it was like, it's all statistical. Like it's just predicting the next word or token or however you want to say it. And it's basically, that's why it takes so much energy, because it's basically having to do like a massive statistical analysis for every single letter, or even like, I think now it's like string of words, but it's basically like what string of words make sense to go next? What token makes sense to go next? And it's incredibly energy intensive to do all that statistical analysis. But according to Melanie and her and the research that this community is doing, the jury is out, y'all. The jury is out. Maybe there's some researchers that are saying, no. These AIs have evolved. They are actually creating world models. Then she goes on to talk about some definitions of a world model, and all these definitions are really confusing. This is where I think OOUX can help out. I will give you my definition of a world model, and this should come to no surprise to my OOUXers out there. Basically, a world model is being able to understand, or an understanding of, the objects or concepts in a system, understanding what they are, how are they actually defined, understanding how they are connected in context to each other, understanding also what types of people or roles or other factors can act on those concepts, what can be done to those concepts or things, how can they be manipulated, and then finally, what are the individual parts of those things? How are those things broken down? What is their chemical makeup? And in OOUX, we call this core content and metadata. But basically, how are those things categorized? What are the different aspects of those things? And so once you can, quote, understand that, you create what she goes on and what these other people have made definitions to call this world model, this kind of compressed view of the external world. And that's why when we create our mental models or our world models or our models of a certain problem domain or problem space, this is a really efficient way actually to understand a system, to go in and be like, okay, like I can make these generalizations about things. So when we understand something, it's not like we just know everything about a certain problem domain, right? Like, and this is actually, as a side note, this is what I think a lot of UX designers are trying to do when they go into a new problem space. They're trying to train themselves sort of like how we're training our LLMs now. Let's just take in all the information and hope, fingers crossed, that understanding emerges. And the leg up that so many OOUXers have is they go in with tools to be like, no. I know how I can start constructing my world model in a really intentional way. And I can start picking out the objects and start mapping those relationships and start logging what can be done to all these objects and what their attributes are. We can get a really quick understanding. And then with that understanding, we can ask really good questions. We can design really elegant systems. We can communicate to other people in that domain in a really efficient way. We've basically created this kind of compressed understanding of the world or of a problem domain instead of just like, let me read everything about it. And then hopefully I can pull out a bunch of facts and then sort of simulate understanding, which honestly, that's what I was doing at the beginning of my career. I was just trying to take in as much as possible and hope that I can simulate and get by with enough understanding to actually get the job done and feel like a valuable, smart person on a team. And there's a better way. So, okay, moving on with the article, I just want to actually quote how she sums up these definitions. So she says, these informal definitions emphasize that world models exist in an organism's brain, or say an LLM's neural network, that they can capture something about the world that is causal and abstract or compressed, rather than simply based on large sets of statistical associations. They don't require too much work for the agent to use. They're algorithmically efficient and are relevant to tasks the agent performs. All right, cool stuff. Are you staying with me? You're staying with me. Awesome. Okay. So to summarize, AI is becoming less brittle over the last couple of years. But AI researchers don't know if that is because AI just has way more coping mechanisms to get around its brittleness, or if it's actually constructing a world model. And the definition of a world model is also debated. Okay. But I think within OOUX, we can kind of agree that a world model really aligns to ORCA. What are the objects? What are the relationships? What are the calls to action or actions, roughly, on those objects? And what are the attributes of those objects? And if a entity has a really good understanding of all that and all the intricacies around the 4 pillars of ORCA, you basically have a world model right there. If you're looking to learn more about OOUX and the ORCA process, make sure that you go register for the UX Level Up. This is my absolutely free 90-minute training. You can go to OOUX.com/UX Level Up to get my 20 most juicy and potent and actionable and not fluffy at all ways to level up your UX career. These strategies will give you the outline of the ORCA process and help you start using it immediately to level up your career. So go to OOUX.com/UX Level Up to register for this completely free training. Hope to see you there. Thank you so much and happy OOUXing. Okay, so as Melanie continues the article, she goes through some really, really interesting, exploration of the different levels of a world model. I think it's really, really interesting, but I'm skipping over that. You can go read the article. Okay, to further sum up part 1, let me give you what Melanie says. She says, clearly it would be very useful for AI systems to have the kind of internal models that enable reasoning about the world. Indeed, many people have claimed that without such internal models, AI systems can never attain human-level intelligence. So, if we want that, debatable if we actually want that, but if we want that, if we are going in that direction to have AIs that have human-level intelligence and the efficiency that can come with that, we really want our AIs to have a really awesome world model. Okay, so moving on to part 2 of LLMs and World Models by Melanie Mitchell. She goes into the evidence for and against these emergent world models. All right, so she goes into this study on a game called Othello. This is very, very interesting if you want to get into it, but it goes into, this is like, as of now, like one of the biggest, for the proponents that have people that are saying, yeah, AI is creating a world model for sure. This research is become sort of like the case study for that, but not everybody agrees. It's a lot of back and forth. So basically what happened is these researchers trained the Othello GPT on 20 million sequences to say this is how this game is played, but it didn't actually give it any explicit information on the rules or the concepts, okay? It just was like, here's a bunch of sequences, have fun, can you make sense of it? And there was a lot of evidence that said it did make sense of it, that it actually did develop a world model about the game, but it's debated still, right? Which again is so funny. And it's really interesting to read the article and go into how they are determining this, how they basically create another AI to go below the hood and really see how the Othello AI is thinking. My question here, and I would love it if anybody wants to jump in, is if we know a world model creates better efficiency, wouldn't we just see it in the efficiency? Like, what am I missing here? Like, if it is creating this compressed worldview, it being for example, the Othello GPT, if Othello GPT has created a compressed worldview on like what a white token is versus a black token versus the game board versus players, how they interact, what are the rules of the game, what are the things, what are the relationships, what can the players do to the things, and what is the meaning or attributes behind those things, all of that. What does it mean to win a game? What is the concept of a game? What is the concept of a player? All that good stuff. If it was able to do that, wouldn't the system be more efficient? And couldn't you just measure the efficiency? And shouldn't it kind of gain efficiency as it learned? I am unclear on that. I would love to hear. We can comment in Spotify or wherever you're listening to this podcast. If there's comments below, like, let me know what you think. And if that makes sense or not, or why that doesn't make sense, because it doesn't seem like that's what they're doing to try to determine if a world model is emerging. So just curious. So the article kind of shows the whole back and forth between this. So one interesting argument for this Othello GPT to have created a world model to create true understanding or human-like understanding is actually its ability to classify squares instead of just a black, white, or empty as mine or yours. So actually getting into the context, and it was able to do that with some tweaking. So this led the researchers to be like, it is really understanding context. So, which is something that we talk about in the OOUX world, the concept of mine and yours, and how this is a level of thinking that kids learn relatively early on as far as metadata on objects is ownership. And it is a sign of intelligence, actually. It's a sign of growing maturity to be able to understand the concepts of mine and yours. And the fun side note of like, lots of parents can attest to this, that, nouns are what come first as far as words. Adjectives start to come. There's a few verbs that get rolled in there, but usually mine and yours comes before some of the very first verbs, which is pretty funny. Mine. Probably mine is what comes first, right? The concept of mine, and they often get that wrong. They just think everything is theirs, right? But they're playing around with this concept of ownership, which is very interesting to me. So as Melanie is showing and illustrating this back and forth within the research community, this debate on is the Othello GPT actually creating a world model or not, I just want to quote her right here. So she says, but the question still remains, does this all mean Othello GPT and other such transformers have indeed developed implicit world models? If so, what kind of world models have they developed? And I think this is so key, all right, because I think this is one of the things, if they are creating these world models, what models are they actually creating? Because we're just feeding them a bunch of data, all right, and hoping for the best, that the world model is something that aligns to how we see the world, right? But if some of that data is crap that it's getting, right, which we all know, like the data, it's not all good data that's going in there. It's not all true data. So it is creating potentially a world model might be emerging that doesn't align to our human world model. And this gets to my big question here that I would love to talk to people more knowledgeable than me about. Why are we not training the AI on a world model? Even at a micro scale. So this is how I have been basically training my custom GPTs that I've been creating, is I train them on a world model. I basically create an OOUX. I OOUX whatever the problem domain is, and I say, okay, here's the concepts you need to know. So when I am training when I'm customizing a GPT, I'm not really training it because, that's not what I do. I am customizing the GPT. So when I go and I customize it and I refine the GPT to be custom to what I want, I am trying to give it a world model. I give it a glossary. I give it a bunch of definitions. Okay, for you in context, this is what all these words mean. This is how all these things relate to each other. This is basically what can be done to these things. And here are the attributes of these things that I care about. All right. So if it's a gardening custom GPT, which I have one, I give it okay, here's all the attributes for plants that I care about. I want to know whether it's native or not. I want to know whether it is evergreen or not. I want to know its historical context. That's, just for me, right? Some people won't care about that. So I am giving, and I also want it to know what my beds are, right? So my gardening beds, and how different plant varieties are going to relate to the sun and gardening beds and my seasons and my location, right? So I am trying to customize it based on a world model, and I've had a lot of success with this. Okay, so I am being really, really intentional when I train I keep saying it's hard not to say train, when I customize a GPT. This is what my AI for OOUX and OOUX for AI mini course is all about. I will link that below if you're interested in that. Is basically OOUXing the problem domain so that then you can create an artificial intelligence, an agent, if you will, when you're designing that agent that really understands the truth about your particular world. So if you are, let's say you're working on an agent for, let's say, oncologists or something like that, to go back to our cancer example. So what you would want to do is you would want that AI agent to share the same problem domain world model as the oncologists, right? And what's important to them. So this gets to my question. Why are we just shoving it with a bunch of data and hoping for the best and hoping that a world model aligns? I mean, I think I know the answer to that question is because mapping out a problem domain is hard, but it's not impossible. And it might actually be a whole lot easier than kind of crossing our fingers and just seeing, okay, what kind of world model is emerging here? I don't know. Well, why not be really intentional about it, I guess is what I'm saying. And this is such kind of good news for OOUXers because it makes us really, really valuable in the AI space, because what we can do is we can say, all right, let's customize this particular agent so that it has a really good understanding of, quote unquote, the world model. I would say the problem domain model. Like, problem domain modeling is what we do in OOUX, basically, right? So if we can train the AI on that model and then give it lots of data sets, right, that kind of match up to that, will we get much better results and a less brittle agent? So Melanie wraps up part 2 with this, and let me quote her here. Today's LLMs are clearly much less brittle than the neural networks of before times that I talked about in part 1 of this post, but they still exhibit brittleness, possibly due to a similar reliance on a bag of heuristics, albeit at a much larger scale. Humans probably use a mix of abstract world models and a bag of heuristics for problem solving as well. But I think it's likely that humans don't have the same capacity as today's LLMs to learn enormous numbers of specific rules. I guess that it's actually our human limitations, constraints on working memory, on processing speed, on available energy, as well as our continually changing and complex environments that require us to form more abstract and generalizable internal models. Perhaps we will need to constrain and challenge our machines in similar ways to get them to think more abstractly and to be better at generalizing outside of their training data distributions. Go back 30 seconds and listen to that again if you need to, okay? Because that is what Melanie is basically proposing. Is let's give it some structure. So it's like we just give it a bunch of blobs and hope that structure emerges. Why not give it the structure and the blobs? Why not constrain it in some ways, basically, to not only create a more useful system, but a more efficient system that can run hopefully on a little less energy too. So in further conclusion, the claims of emergent abstract world models are not yet supported by strong evidence, to quote Melanie. She goes on to say, moreover, the notion of world model itself is not rigorously defined. When considering whether an agent has a particular kind of world model, we should ask what kind of questions such a model should be able to answer. How easy or hard should it be for the agent to get answers from the model? And to what extent would we expect the model would allow the agent to adapt to novel situations? Okay, so going back also to, I have just one more thought for you. What kind of questions should a model be able to answer? This actually gives us the questions we ask in OOUX basically give us a really good set of questions that we could kind of kick the tires on an AI agent to be able to see, like, does it have a world model, or at least does it have the strength of simulating a world model, okay? So we can test the brittleness of our AI by basically asking it questions about the objects, the relationships between objects, what different roles or different parties can do to those objects, and asking really tough questions about the attributes or the aspects of those objects. Okay, so if you have a custom GPT or you're working on some sort of AI agent, this would be a really good way to test the robustness, the strength of it, is to basically ask it these OOUX-y type of questions that we end up asking developers and stakeholders and our clients. We can ask our AI agents as well. So finally, in further, I think I've said in conclusion like 8 times. So sorry, I'm actually ending now. The beauty of all of this is that our skills in being able to construct models of a problem domain, I predict, and it sounds like Melanie is kind of predicting too, this is going to be a power skill in the age of AI. And that is very exciting. A little scary too when we're thinking about like, oh God, is OOUX going to help bring on real sentience? And I've posted about this on LinkedIn before about like, once AI can do this, does that make it sentient? I said I was ending, but I have thoughts on that too. And then I'll wrap up. Once an agent can start to identify objects in a system and their relationships, et cetera, it can start to identify itself as an object in the system. If it has that ability, right? If it has the ability to create concepts and connect concepts and to truly have an understanding of those concepts, then it can be a concept. And when it becomes a concept, it can have attributes as well and relationships to other things and things that it can do and that can be done with it. And does that then bring us one step closer to an AI agent having actual opinions and feelings about it as an object in the system? The reason we are self-aware and we have our own consciousness and we see ourselves as entities within a system, right? And we can move through that system and think of ourselves as having free will is because we see ourselves as objects. As objects with edges, right? And that have relationships to things in our environment, but that we are a discrete thing. And that we can be categorized in a certain way. We can do things versus not do things. Things can be done to us, and those things that are done to us or that we do can be good or bad. All right. So I do think this is a step towards sentience. I think it's going to happen one way or the other, but I would love to see it happen in a way that is much more intentional and much more energy efficient. All right. I am so excited to hear what y'all think about this. Tell me where I am off the mark. Melanie, if you're listening, I love your stuff. It is so great. Tell me again what makes sense, what doesn't make sense, what questions you have. Let's talk about this. I hope you found this interesting, and happy OUXing.
Thank you so much for listening. I truly hope you enjoyed this episode. Please visit objectorientux.com/podcast for show notes. Our soundtrack is Fighter by Ruby Vell, courtesy of Sugaroo Records. Happy OUXing!